guys, today I'm going to be talking about the area and volume of 2D and 3D shapes. As you can see, I've already completed how to do like the different formulas, and I'll be explaining how each is done. So looking at the area of 2D shapes, first we have a square, which is up here, and then we also can think about the fact that it's similar to a rectangle, and you would use the same formula to complete it. So over here I have written that this formula is area equals length times width. As you can see, this over here, this dimension, it would be the length, and this one down here would be the width. So I'll just rewrite length and width. Now, since the square has the same dimension all across the different four lines of the square, you could use one variable as x. So you could do either length times width, or you could simply do x squared. And the reason why you're squaring it is because you would do x times x over here, as it would be length times width. So you're doing x times x if you choose one variable, and x times x is the same as x squared. So you could choose length times width or x squared. They're both the same thing, it's just the way that you would prefer it. Now for a right angle triangle, which you would determine if it has this line over here, you would have the base times height. So the base is down here and the height is on the side. So you would get the base times by the height, and then you're going to divide it all by 2. And the reason why this happens, I'll show you, is a square, right? You have length times width. Now essentially you're using different variables, but you're doing the same thing. So suppose if we had changed this and we did length times width divided by 2. That works. It's just that base times height would be more acceptable, and it's kind of about the way you would understand it. So you have this color over here. So you have square. As you can notice, a triangle that's a right angle one is half of a square. That is why you're dividing it by 2. Next, you have a shape which is called rhombus. Now to get a rhombus's area, you would do P times Q over 2. And as you can see, we're literally doing the same formulas, just changing up the variables. So Q would be this distance, this is Q, and this one would be P. Now for circle, you would need the radius over here, and then you would do pi r squared. And then for this shape, which is a parallelogram, you got the base right down here, and then you got the height. It's a straight line down, not the tilt. It is a straight line down. And then you would do base times height. And here's a practice problem. Up here, so you can see we've got the height, and here we've got the base. So you do the formula for right angle triangle, which is base times height divided by 2. As you can see that the base is 8 and the height is 5, and then you would divide it all by 2. So the top fraction, 8 times 5, is 40 divided by 2. That would equal to 20. And since this is the area, you have to make sure you always add the units at the end no matter what. And once you've added the unit, you have to make sure you add the squared up here. It's very important for areas. Next, what we have is surface area and volume of 3D shapes. Starting off with the cube, we have here the surface area would be 6x squared. Now the reason why we're doing 6x squared is x squared would be the formula for just one square, and since the cube has 6 squares, you would times it all by 6. The volume would be x cubed, which is x, and then exponent of 3, or x to the power of 3. And the reason why is typically you would also see the formula length times width times height. Now, since up here we decided instead of using length times width, we're going to use the exponent x, then you would do x cubed instead. Now we have a cone, and the formula for surface area is pi rs plus pi r squared. As you can see, if you have the different parts labeled, and you would input them accordingly or try to understand the way each one works, and the volume would be b times s over 3. Essentially, this could also be bh over 3. It's just the way that you want to understand it. It's the way you write each formula, which exponents you choose. Now the next one we have here is a triangular pyramid. This specific one is kind of a little different on the basis of how to understand it, and it's really just harder to explain as well. It's more so of how you understand it. But some key pointers are this line over here. So that's the slant height. Now, how it differs from the actual height is the height is from like point A to point B, straight down. It doesn't matter what is going on here or here, it's just line down. Now, the slant when you have a triangle. So suppose this is the line for the height. The slant, it would be the actual like length of this face of the triangle. And the pyramid meter, it would typically be of the base. You just have to try to understand more. It can be a little difficult, but with practice, it is possible. And the volume for this would be B times height, which is base times height over 3. For the next shape, to get the surface area, you would need to understand that P is the perimeter of the base. So you would do 2B plus 2P, and the volume would be BH. And it's the same volume for the one that's next, which is a cylinder. The volume is also BH. And the surface area is different. So as you can see, the second part, it's related to a circle, pi r squared. That is the formula for a circle. And since there's 2 circles, 1 and 2, you would have 2 pi r squared. And then this one over here is representing this shape over here. And we already covered the volume. And the last shape we have here is a sphere. We have surface area is 4 pi r squared. Pi r squared, again, is just, it's for a circle, and you're doing 4 because it's a cube. And the volume is pi r cubed times 3 over 4. Once you input the different things, it would make more sense, and you can also do it on a calculator to make things easier. Here's a practice problem over here. So we have a surface area is 2b plus 2p. So we have 2, and then we've got times 5 plus 2 times 3.5. So the first half, this is equal to 10, this is equal to 7, equals to 17 centimeters. Since it is the surface area, you would have just the centimeter. And as you can see, this is the base and height. We have to actually add the cubed over here, like so. And since the surface area, we would add cube, we have to add squared over here. So exponent 2 and then exponent 3 up here. So base times height, 5 times 3.5 is equal to 17.5 centimeters cubed. So that is the volume, that is surface area, and these are the formulas. I hope you guys understood. Good luck.